In the previous problem, we have seen the utilization of the mud taken out of the well for making a platform separately. But in this problem, the mud taken out of the well is used for making an embankment around the well. Platform is typically in cube or cuboidal shapes, but embankments will be in hollow cylindrical shape. So why hollow cylinder here? If I draw the diagram, then you can understand in a better way. Now you can see the red color structure. This is called the embankment, which is around the well. So what really happens in reality is, when anybody wants to fetch water from the well, they just hop on that embankment and drops a bucket into the well and get some water. So it works as the elevation for fetching the water from the well. Now I am marking the dimensions of this well and hollow cylinder. Please observe very carefully. I can take small r as the radius of the well, and the inner radius of this embankment is also smaller. The outer radius will be taken as capital R. If you want to see the top view of this structure, so that is a circle for well. Around this yellow circle, I am drawing one red color circle, which is the outer wall of this embankment. Now whatever marked in green color, this is the surface on which people can stand and fetch the water from the well. So the top view is clearly saying it is a hollow cylinder. As far as the heights are concerned, I can take capital H as the height of the well, actually the depth of the well, and the height of the embankment I am taking it as small h. Now map all these letters with the given dimensions in the question. The inner radius is 4 meters, capital H is equal to 14 meters. The width of the embankment is given as 3 meters. So I can take W as 3 meters. In order to do something with the hollow cylinder, we should find the value of R, but we don't know it. If you carefully observe, capital R is equal to width of the embankment plus radius of the well, otherwise inner radius of the embankment. Let us substitute the W value and R value here so that we'll get 3 meters plus 4 meters respectively. Then we'll get the outer radius equal to 7 meters. Now we have all the weapons to find out the height of the embankment from the known formulae. Here also the volume conversion is clearly happened. Whatever the earth is taken out of this well is used for making this embankment. That means the volume of the well is equal to the volume of the embankment. The well is in the shape of a cylinder, so we have to apply volume of cylinder formula, which I can take it as pi r square h equals to. The embankment is in the shape of hollow cylinder, so that I have to apply hollow cylinder volume formula, pi h into r square minus r square. On either side I can cancel this pi out, and now let us substitute the values which are given in the question. So small r value is 4, so it is 4 square into the depth of the well is given as 14 meters. In place of capital H we are going for 14 equals to, we don't know the small h value, which is the height of the embankment, so that's why I am taking h as h itself into r square. Just now we have found out what is capital R value, which is 7, so it is now 7 square minus small r value we know, which is 4, so that's why it is 4 square. Now here the only unknown is small h, so by simple simplification we can find out what is the value of small h. Here I am using a square minus b square equals to a plus b into a minus b. Finally we got the small h value as 6.78 meters. So which means that the height of the embankment around the well will be equal to 6.78 meters. Even in this problem we have used the concept of volume conversion. Volume of cylinder is converted into volume of hollow cylinder, as opposed to volume of cylinder is being converted into volume of cuboid in the previous problem.